What is temporal resolution for Earth observation satellites? Imagine trying to catch a fleeting moment in a busy city street. How often you look determines what you see. That's what temporal resolution is all about for Earth observation satellites. It tells us how often a satellite can revisit and capture images of the same spot on Earth. This is also called the revisit rate or repeat cycle. It's usually measured in hours or days. High temporal resolution means the satellite can take pictures of the same area many times within a single day. This allows us to watch quick changes like a wildfire spreading or a flood unfolding in near real time. Low temporal resolution means the satellite images the same place less often, maybe every few weeks or even months. This is useful for tracking slow changes like urban growth or seasonal vegetation cycles. Different types of satellites have different revisit capabilities. Satellites in geostationary orbit stay fixed above one spot on Earth, giving continuous observation of that area. They have the highest temporal resolution but usually less detail in the images. Satellites in polar orbits circle from pole to pole and revisit the same location every 1 to 16 days. These are often sun-synchronous, meaning they pass over the same spot at the same local time each day, providing regular updates. The width of the sensor's swath, or the ground area it covers in one pass, also affects how often a satellite can revisit. Wider swaths cover more ground quickly, reducing the time between images. But wider coverage can sometimes mean less detail in the images. The type of sensor matters too. Optical sensors need clear weather and can be blocked by clouds, which reduces effective revisit frequency. Synthetic aperture radar sensors can see through clouds and provide more consistent data, especially during bad weather. Modern satellite systems can be tasked to focus on specific areas during emergencies, like floods or wildfires, to get more frequent images. Satellite constellations, which are groups of satellites working together, can also cut down the time between revisits. There's a trade-off between temporal resolution and other types of resolution. Higher spatial resolution images show more detail but often have narrower coverage, which means less frequent revisits. Increasing spectral resolution, or the ability to distinguish different wavelengths, can also limit how often data is collected because of larger data volumes. In real-world applications, temporal resolution helps us monitor fast-changing events like storms, wildfires, or crop growth. It supports disaster response by providing timely images for damage assessment and recovery planning. It also helps track urban sprawl and environmental shifts over time. Knowing how often a satellite can revisit a location helps users choose the right data for their needs. Whether they need frequent updates for emergencies or less frequent images for long-term studies, understanding temporal resolution ensures they get the information they need when they need it.